The last couple of videos, we talked about measures of variation for data where it was in relation to the mean, where the measure of center was the mean. So when you're dealing with the mean, we talked about this mean absolute deviation, which, as a reminder, is just the average distance of every point in a data set from the mean. And when you're using mean as your measure of center, the mean absolute deviation is a good choice to talk about the variability. However, now we're going to talk about what happens when we're using the median as our measure of center. And in order, we're going to use something called the interquartile range. And I'll explain what that is in a little bit. And before that, I need to talk about the idea of percentiles and how we can visualize all this in something called a box plot. So the interquartile range is going to stand in for our measure of variability here. The last thing I want to say is we didn't really cover how to take percentiles for any percentile. There's lots of different ways to do it. That's the thing. There's no strict definition of a percentile because the various different definitions differ so little when you have large data sets, it doesn't really matter. But if you need to find other percentiles, you can look up how to calculate them. There's something in our textbook, and any good textbook that has something about ordered data and statistics and box plots in it. So you can look it up how to calculate, or you could just look it up on the internet. There are loads of good resources on the internet to help you there. So in order to talk about the interquartile range, I need to explain what percentiles are. And we're just going to have a bird's eye view of percentiles, because we're only going to care about 3 different percentiles. One of them we've already talked about. But the idea of a pth percentile, it's a number where if you have a data set, then p% of the data is less than or equal to that number. Let me give you just a little example here. So suppose we had a data set here, and I said this p percentile is maybe 100. So if this is and let's say p is the 90th percentile. That's 90th percentile. So that tells me that 90% of the ordered data is less than 100. And of course, 10% is above 100. So that's kind of the idea there. A percentile, it just says, well, if a number is a certain percentile, that percent of data is less than that number. So that's all a percentile is saying. Ones we're going to care about, we will care about the following. So we're going to call it the lower quartile, which is, I'll write it in words and I'll explain what it is as a percentile. And you think quartile, that has something like the word quarter in it. So we're going to divide things into 4s. So the lower quartile is the 25th percentile. And I'll write percentile for percentile. We care about the median. The median is in fact a percentile. Because remember, that splits the data exactly in half, which means 50% of the data is below the median. So the 50th percentile and the upper quartile, which we'll call QU, which is the 75th percentile. So 75% of the data lies below the upper quartile. And the way it's going to look is as follows. So basically, the way it'll work, and I say basically for a reason, so we're going to have these dividing lines. We're going to have our lower quartile, our median, and our upper quartile somewhere. And in each section, we're going to have 25% of our data. So that's why they're called quartiles, because they're the places that break up your data into 25% chunks. So we get a quarter of the data in each section. Below the lower quartile, between the lower quartile and the median, between the median and the upper quartile, and above the upper quartile. Now, I will say the following thing. So I put a little asterisk here talking about percentiles being less than or equal to that number. And it turns out there's no real standard definition for percentiles and quartiles. And it really doesn't matter when you have large data sets. So this is no standard definition. And if the data set is large, then it doesn't really matter anyway. It doesn't matter what you pick. So the way we're going to do it is we're going to calculate these quartiles with this less than or equal to definition. And the other thing is we're going to exclude the value if it's actually part of our data set. If you have very large data sets, it won't really matter. But for small data sets, you have to be a bit careful. And since we're going to be dealing with small data sets just because we're learning, we're going to have to care about this. And one more quick note, there are two other values we're going to care about, and I'm just going to mention them. So I'm going to scroll down here. So the other two values we're going to care about in our ordered data set are the maximum, so that's the largest data point, and of course the minimum, which is the smallest data point. And all of these together, so we call the min, the lower quartile, the median, the upper quartile, and the max. So those five numbers are called the 5-number summary. Of a data set. And that's going to be really important when we start graphing these things. We'll need that 5-number summary to help us graph. Okay, so suppose we do want to find a 5-number summary of the data to break up our data into quarters. So the first two numbers are kind of the easiest to find, the minimum and the maximum. That's, of course, the largest and smallest elements of your data set. So here's an ordered data set down here. Of course, the minimum is -2. The maximum is 90. That's easy. So we have those two numbers for our 5-number summary. We just need to find the other 3. Okay. Oh, and one quick note. I put these into numerical order before I wrote them down. But if you have a data set that's not in numerical order, you're going to have to order these from smallest to greatest. Okay, so now that we have the min and the max, let's find the median of our data set. You can count these. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 data points. So the median, the index of the median, so it's going to be 13 plus 1 over 2. 14 over 2 is 7. So we need the 7th data point. That will be our median. 1, 2, 3, 4, 5, 6, 7. So there is our median. I'll do it in blue, I guess. Median M, or 50th percentile. And you can see this splits our data into 2 halves. So disregarding the median itself, because it appears as an actual data point, because it is an actual data point, we have 6 pieces of our data below and 6 pieces of our data above the median. So it splits our data set exactly in half. Now, disregarding the median because it's an actual data point, this splits our data into 2 halves, and the upper and the lower quartile are going to be the medians of these 2 halves, the medians of the half data sets. So you can count here in each half we have 2, 3, 4, 5, 6 data points. So we need, you could calculate the index of it, but I think it's pretty easy to see that we need the average of these 2. And you can check that the average of 7 and 13 is 10. So 10 is going to be, it's the median of the lower half of the data, so it is the lower quartile. And similarly, in the upper half, we have 6 data points, and we need the median of this guy, and that's going to be the upper quartile, Q, U. So 63 plus 71 divided by 2 is going to be 67. So there is our 5-number summary. And you can see what's going on here. So our data is split up into equal chunks. So -2, -1, and 7 are all less than 10. That's our first 25%. 13, 19, and 27 as our second 25%. We're disregarding the median because it's an actual data point. Our third 25% between the median and the upper quartile is 44, 59, and 63. And our fourth 25% of the data is 71, 72, and 90. And when you have larger data sets, getting rid of one element of your data set isn't going to make that much of a difference. But with small ones, it kind of does. But just so we have some workable size of data sets, we're just going to do it like this. So hopefully that idea is clear, and we can write down our 5-number summary. Let me do it in black. 5-number summary. And I'll just list it in order. Here's the min is -2. Then it is the lower quartile, which is 10. the median is 36, the upper quartile is 67, and the maximum is 90. So maybe let's do another example of finding a 5-number summary and see how it goes. Okay, let's find the 5-number summary of this data set. Again, I put it in order. You should always order your data set from least to greatest when dealing with anything in terms of order data like medians, or if you need to figure out percentiles. So our min is obviously 3, and our max is obviously 9. So we need to calculate the median. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So we need the average of the 5th and the 6th. So it's going to be these two. So we'll take the average of these two. And the average of 6 and 6 is, of course, 6. So note that the median in this case is the average of two values, so it's not an actual data point. So we're going to split our two halves like that. Unless we have an odd number of data points and the median is actually a data point, we're going to keep those two constituents of the median in this case as part of our halves. So we have a half of 5 and another half of 5 points in our data. So we need the average of those, or sorry, the median of those. So the median of each of these, there's 5 data points. 1, 2, 3, 4, 5, and it's pretty easy to see that we need the third data point in each set. So the lower one is going to be our lower quartile, and the upper one is going to be our upper quartile. And our 5-number summary is going to be 3, 4, 6, 7, 9. And that's how to calculate a 5-number summary from a set of data. In the next video, we'll talk about how to use this and how to graph these in something called a box plot. And then we'll talk about outliers and how this measure of variation called the interquartile range can help us determine when values are unusual.